Hey everyone, this is Mr. Garcia, and today we will go over notes 1-1, relations and functions. But before I go into the lesson, I'm going to ask you to write your name on the upper right hand corner of your notes. Okay. Next, I also want you to notice that I'm using different colors on my notes. Now, do you have to have the colors I have? No, you don't. What I'm going to look for is just that your notes look exactly like mine. Okay. All right. So having said that, let's get started. There are 4 ways to represent a relation. One is a graph, ordered pairs, table of values, and a mapping diagram. Now, you might be asking, what's a relation? Well, a relation is a set of pairs of input and output values. So let's take, for example, ordered pairs. You have input, you have outputs, okay? So X is the input, Y is the output. So say for example, -5 here is the input, 1 is the output. So this is an X value, this is a Y value, X value, Y value, and I hope you get the idea. X values always come first, Y values come second. All right, so this is one way to represent a relation. Another way is by a graph. If you look at this point, this is -5, 1, which is this point. This one is -3, -2, which is this point. And this one is -2, -5, so that's this point. This one is 0, 0, which is this point, and I could continue, but I hope you get the idea that this graph also represents these, this set of ordered pairs, okay? Now, what about a table of values? -5 and 1, there, -2, -3, -2, here, -2, -5, also there, 0, 0, also there, so that means these 3 so far represent the same relation, okay? And this one, -5 goes to 1, -3 goes to -2, -2 goes to -5, so you get these 3 points and also 0, 0. So again, this mapping, this set of ordered pairs, this graph, and this table of values represent the same relation, okay? So let's go on to something else for this one, okay? So that's just to let you know you have 4 different ways to represent a relation. Now, there are some rules and guidelines that we follow when it comes to relations and functions. And the first rule I'm going to talk about is listing values in order from least to greatest. Okay, so take for example, I have this arrow going here. Look at the X value, so I'm saying X's only. They go from least to greatest order, but not the Y values. Okay, that's only for a table. Also, on ordered pairs, you have X's only with ordered pairs should be in order from least to greatest. Okay, so -5, -3, -2, 0, and I hope you get the idea. That also applies to a mapping. So for the X values, they should be in order from least to greatest, and it also applies to Y values from least to greatest order. Okay, and that will also apply to the domain. When you write the domain in this form, which we'll get to in a moment, okay, you only do it from least to greatest order, and the same goes with the range, which is the Y values. You go from least to greatest order. The second rule. Okay, so the second rule is no repeats. So when you have a repeated value, you don't list it. Okay, so no repeats on the Y values here, no repeats on the X values, okay, on a mapping, and also no repeats on range, and no repeats on domain. So watch, for example, look at this table of values. I have -2 here, and also -2 here, so I have -2 repeated. Okay, I have it twice. But on the range, I only have it once. Okay, so the point is you don't repeat the same value twice on range, domain, X values and Y values. Okay, so let's continue. Okay, so let's remind ourselves what is domain and what is range and what makes this relation a function. Okay, so we're saying yes here, but let's understand why. So domain is a set of inputs, also called X coordinates, in a relation. Range is a set of outputs, also called Y coordinates, in a relation. And the definition of a function is a relation that has only one Y value for every X value. In other words, the X value, input, or domain cannot repeat. Okay, so let's look at this table of values, for example. Notice that the X values are in order from least to greatest, okay? And no X value here repeats. So that meets the definition of a function, because it's only one Y value for every X value. Since we have that here, that no X values repeat, then we circle yes for this one. Why? Domain which means the x values did not repeat. So that's why this relation is a function, okay? So let's continue on to the next part of the notes. So I'm going to go over these examples here, and this will be the first example. So examples: list the domain x values and the range y values and determine if the relation is a function. But so keep in mind, don't forget the definition of a function, okay? So if we look at this mapping here, we see that -5 goes to -1, -4 goes to -2, but also -5 goes to -3. So if we were to list this domain and this range, we would do it in the following form. Don't forget, they have to be in least to greatest order, okay? So this will be the domain, -5, -4 from least to greatest, and the range is -3, -2, -1, again, in order from least to greatest. Now, the question is this relation a function? As you can see, -5 goes to -1, and it also goes to -3. So that means that this does not represent a function. Why? Because the -5 repeats, okay? And I'll show you that in a moment. So non-function because the x value of -5 repeats. So let's go on to the next example. On this one here, we're given a set of coordinates, okay? And I've underlined the ones with purple, and I'm sorry, the x's with purple and the y's with red, okay? So to get the domain from here, don't forget, always start in order from least to greatest. So let's look at the domain. Domain, -4 is the least, and the greatest is 2. So I have -4, -2, okay, so -4 coming from here, -2 is this one, and then the next one is 1, and 1 is listed twice, okay, and then, or repeats, okay, the 1 repeats, and then 2, so that's this one here. And then we have the range in order from least to greatest. We start with 3, that's the least, okay, so that's this one here, 5, that's there, 6 is this one, 8 is this one here, and 9, it's that one. And again, in order from least to greatest. Now, the next question is this relation a function? And the answer is, this is a non-function. Why? Because the x value of 1 repeats, okay, so this is a non-function. Let's go on to the next example here. So notice that I have a graph. Okay, so what happens if I have a graph? I could list all the values on the side of the graph. I have -3 and 4, so that's this point here, -2, -5, that's this one here, 0 and 7, that's this point here, and I'm not going to do all of them. I hope you get the idea, and I'm going to get all the domain and the range just straight from the graph. So let me show you how I would do this. Okay, so say -3, okay, I'm going to start farthest to the left, so this is farthest to the left, this is x is -3, and then it's this one here, x is -2, and then it's this point here, x is 0 here, and then this one is x equals 2, and this one is x equals 4, but I have it twice, okay, and then this one, x equals 9. So again, notice that I have x equals 2, I have it twice, but I'm only listing that value once on the domain. The same goes with the range. The range, I'm going to go from bottom to top. Okay, so the lowest point is this one, so the value of y at this point is -6, and then it's this one, the value of y is -5, and then this one is 0, and then 2, and next one is 4, and then this one is 5, and the last one is 7. So again, you notice that this is in order from least to greatest. Now, the next question is this relation a function? And the answer is, as you can see, x equals 2 is here and also there, so the x equals 2 repeats. So this is a non-function. I'm sorry, the x equals 4 repeats, so this means that this is a non-function. Okay, and I apologize for that mistake. All right, so let's go on to the next page of the notes. Okay, so on the next page, this is something that you saw in Algebra 1, and this is a vertical line test, and the vertical line test states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. Okay, so let's go over these 3 examples. So I'm going to use this piece of spaghetti as a line, okay, and I'm going to run it through each one of these graphs. So let's start with this one here. If I run this line, okay, representing this spaghetti piece, representing a line, as you can see, it's only going to cross this graph at one point every single time. So that means that this relation is a function. Okay, so this graph represents a graph of a function. Let's go on to the second one. If I start running my spaghetti here, or my line, as you can see at several points, several different points, this line is going to hit that graph twice. So let's take this point here and this point, and we can see that if we draw a line, it's going to hit that graph at 2 points. So once we see that this one doesn't pass the vertical line test, which means this is a non-function. Okay, and if we go on to the next one, this one might be a little bit different. Okay, it might be a little bit difficult to see, but if this was thinner, okay, if this was like I don't know, a piece of thread or something, and you run it through this graph, it would only hit that graph at 1 point. So that means that this is the graph of a function. And I'm going to stop this video there, and on the next one I'll cover the next section of the notes, and this I'm going to make 3 videos, okay, for this one. I hope that helps you, and if you have any questions, please send me a text message on Remind, send me an email, whatever it's easier for you, and I'll get back to you as soon as I get a chance to reply. Okay, thank you for watching.